Okay, so we're going to talk about logarithm. What in the world is log? And so this is an interesting concept here. I will talk about this a lot. This one has nothing to do with logs, but it has everything to do with math, right? So, but before we talk about logarithm, we're going to talk about this picture. This is a cycle of math that we really focus. So start with the input to the function. I get output. Now, if you realize that, we do that in Algebra 1 and Algebra 2 a lot. Okay? So, you ready? Input, function, output. Input, function, output. Right? Kind of like amigos. Input, function, output. Input, function, output. Input, function, output. Right?
Just like just like
Walk like a talkie. Walk like a talkie. Right? So, it's like we've been doing that all the time. But the problem is there's a slight problem. It's actually input, function, output, and there's the back cycle. The back cycle is the inverse function. So you can take the output into the inverse function and get you back to the input. Right? Input, function, output. Input, function, output. Right? So I don't know how to rhyme. Like llama. You ever seen that? You saw? No. You take a children's book and you start rap with that. So I was watching that video. I was trying to catch up to pop culture. You know, I try to have a same dial like as you guys. So I try to learn. As much as like you guys always like you guys don't want to learn from me. I really want to learn from you guys. So you guys can teach me. I'm more than willing to listen. Okay? So input, function, output, but we're going to focus on the back way now. In a precalculus, it really focuses on the inverse function because everything we do, there's always inverse of it. Everything we do, sine, inverse sine, log, exponential function. And we're going to talk about all this thing. So what is log? We haven't really answered that yet. Let's talk about who got a job in this classroom. Who get a job? Who has a job? What do you do? Babysit. How much hour you get paid?
Depends.
Okay, let's just say normally, last job you get.
I got $10 an hour. I worked all day.
$10 an hour, good. So $10 an hour. So we gotta define a function. Now just talk about, Marion might have $20 to start with, right, before he worked that job. So I have to create a function that model what Marion's work is. So if I create a function that models that, what would it be? Y is equal to what? 20 plus 10x, thank you. Y equal to 20 plus 10x. Because we're talking about Marion, he get $10 per hour. That's start he worked $20. Before he worked here, he had $20, and then he worked $10 an hour. So x represents the hour she worked. So if she worked 1 hour, so she will have total $30.
Yeah, but the 20.
20 is the what money does she start with? She already started $20.
Just randomly. I thought $20
Okay, so you saw $20 on the floor, yes, and then $10 an hour, right? So that means I put in 1 hour, I'm gonna get $30. If I put in 2 hours, I babysit 2 hours, I'm gonna get 40. 3 hours? Okay, so now what is our idea is very, very important. So now you're gonna get that. So now they have the function that takes this back from output back to the inverse, right? So what will be the function that I put in the output is gonna give me that hour.
50 equals 20 plus 10.
So well, not there yet. So what we're gonna do, we're gonna take this function, y equal to 20 plus 10x, right? We can x equal to 20 plus 10x. 10y, right? And I can change that, so it'll be x minus 20 equal to 10y. and then y is equal to x over 10 minus 20 over 10. That's equal to x over 10 minus 2. So now this is the inverse function. So we're going to write down f inverse of x equal to x over 10 minus 2.
Wait,
Yes.
you need to like,
Yeah.
you went
How'd you go
really,
from like
really
10 to
fast.
10 line?
Wait,
You just made the x of y,
You could
right?
put that
can you go back to like y?
So here, I want to find the inverse function.
Okay.
I switch the x and y,
Okay.
right? And I'm going to take the 20 to the other side, subtract 20.
Oh, yeah.
Oh, so basically.
And now divide it by 10. If I divide it by 10, I divide each individual by 10.
Okay. So inverse function, you always switch y and x.
Right, that's what we done before. We spent 3 days on that.
And then you solve,
Yeah.
and then you solve for x, right?
Yeah,
Oh, okay.
I'm solving for y, not x.
Oh, yeah, that's what it is.
Okay, so now, let's say Marion has $60. How many hours does she work? So I can plug in an inverse function, 60 divided by 10, which is 6. 6 minus 2 is 4. So she worked 4 hours. So it's not just an input function output, right? It's actually, you can go in a cycle. It's input function output inverse, input function output inverse. Okay, so they are going in a cycle, right? I can form my new rep album now. I can do that? So now, this is going to go to a cycle. So now, you understand this is a cycle. This is a math, very, very important cycle. That means a car driving forward can drive back. Otherwise, you're going to drive, you park in the garage, you're going to go, Dad, I back up, I got my car out of the garage. And you go into the garage, you just see a hole. And you say, what? He just ran through the wall and he come back out. And I got my car out of the garage. Again, your dad gonna beat the crap out of you, but that's the idea. Okay? So this is the idea that you understand. So now let's talk about why do I talk about this? So it must be some type of function that represents that. So we're gonna this function is y is the output, so input, so it's gonna go backwards. So now let's talk about, we're gonna have this magic jar here. Okay, this is a magic jar. And I wish that this can happen to me. Now this magic jar is my dear jar, okay? So this jar, I put in one marker, okay? So this jar have a specific property. This property says, if I put in one marker, after 1 minute, I will double it. Okay, so after I put in one marker, I will double it, okay? So what I'm gonna do is I'm gonna put this jar, put the thing in the jar. I'm gonna say, hey, I'm gonna put in one marker here, and I'm gonna wait for 2 minutes. I'm gonna wait for 2 minutes. So hypothetically, is, if I close it, so how many markers would I get?
After 1 minute, you wait 2 minutes. 2 minutes, 4.
Okay, I will get 4. So I will say, okay, 1 minute it's over, and the second minute I'm gonna open it. I'm gonna say, okay, now as I take it out, I'm gonna say, okay, this is gonna be, what's gonna be like, okay, what? 4 markers.
Yeah.
Okay.
5.
Oh, 5.
Okay, stop.
But you got an idea. I counted wrong first. Okay, so after 2 minutes, I'm gonna get 4 markers. So that's what something called exponential. Exponential growth is exponential. They grow every minute and they double it. You can grow triple every minute. You can do quadruple every 10 minutes. But that's very important. Okay? So not only that, we're gonna talk about also this. And we're gonna talk about related science, which is we have somebody is really denying science right now. And we probably know who they are, but we're not gonna say his name. Okay, so. Okay, so now we're gonna put in one bacteria. I'm gonna put it in here. And double every second. We can double every second. Okay? This is a very interesting thing. If it double every second, so in 1 second I have 2 markers, in 3 seconds I have 4 markers, in 4 seconds I have just growing, right? Now I wanna ask you a question. How full? Now, bacteria is really small, right? Really, really tiny, small. It's smaller than a marker. It's way small. It's like a dot. It's not even a dot. You can see it. But I'm gonna say, what happened at 1 second before it's full? What happened 1 second before it's full? How full is the jar?
Oh, it's like halfway full, right? Because it's like double, so.
Oh, yeah.
What?
Yeah, like three pieces.
Okay, so it's like if it's halfway full, after 1 second it'll double, so it'll double the whole thing.
So 1 second before that's full, it's only in half. Oh, wow. So that's related to science right now. A lot of time that you guys don't understand how important the global warming is. You don't know. You don't know how important global warming is because the truth is we don't know where the threshold is. We don't know where the threshold is. It's each degree that it will increase among the world, the whole world average. Not just because Florida is cold, the whole world is cold. Right now, it's actually everywhere else in the world, the average temperature is above around 5 to 6 degrees compared to 20 years ago. So that's called climate. Now, climate is the average of everything, not just on average of a month, not just 1 day. Oh, 1 day is cold. Florida, oh yeah, it's cold 3 days ago. Yeah, it's cold, so therefore global warming doesn't exist. That doesn't make sense. That does not make sense. So we get one person that really opposed that. Okay, we can talk about that, but we're not going to talk about it in video. But you probably know who they are. Okay. So the threshold. So let's talk about the bacteria. Let's go back to talk about bacteria. So, and this is a 2 to the 5 equal to 32. What does that mean in that situation? If I put a marker in there, if I put one marker in there for 5 minutes, how many marker I'm going to get, right? So that 5 minutes means what? What that 5 minutes? This is a 5 means the time. That means the input value. What am I going to input? If I input for 5 minutes, I'm going to get 32 markers.
Sure.
If I input for 3 minutes, how many markers I will get?
8.
8. 2 to the 3 is equal to 8. Now think about it. What if I put in 0 minutes?
You get
So
one.
two.
You get
One.
one.
0 minutes, I just put it in. Not just one. Now, let's go back to think about it. How about it already have 1 in the jar at 0 minutes? What happened at -1 minute?
You can't make
It's a half a marker.
But you can't make time.
Because after, let's just say, assume that you can walk, you can go back to the time for 1 minute, and you drive a car, the DeLorean, I think it's called the DeLorean, it's a Back to the Future. DeLorean, you go back to 1 minute ago, that one marker was the half marker. Does that make sense? That's why 2 to the -1 is 1 over 2. Do you see that visually? Do you see that? Do you understand how that works? Don't just because Mr. Ye says -1 power just flip and it become, but you want to understand what is going on. Okay, so let's just say if I put in the jar for 2 minutes, and then I decide to put in for, if I can, I say I'm not gonna take it out. I'm gonna put in for another 3 minutes. 2 to the 2 plus 3 is equal to 32 markers. So that's how exponential rule works.
That's a 5.
Okay, so with that being said, now we're gonna go to, do we talk about converting different form yesterday? So 2 to the 3rd power is equal to 8, and change to the logarithm form?
I think Miller goes from there to
Yeah, right? So 2 to the 3rd power, right, is equal to 8. This is called exponential form, right?
Yeah.
How do we change to logarithm form?
Log.
Log of what?
2.
2 is the base, is a subscript. 8
equals 3.
is equal to what? 3, right? So you draw a heart, right? You can also come back. You can come back to, this is a log form. So 2 to the 3 is equal to 8. So you can go back. Remember, they are like this. They are like this. You can keep on going in cycles. But what does that mean? That just means 2 to the 3rd power. That means after 3 minutes, I'm going to get 8. But this means, what if I have 8 as the marker and the double everything? That's going to give you 3 minutes. So that is the logic behind it, the inverse function. And we talk about those inverse in very, very detail. So those are the things that you got interesting. So you say, okay, I understand what is going on. Now, you got to go back and think about all those things can happen. So let's think about what is, if I'm going to give you 2 questions. So that's 2 to the, let's say 4 power is equal to 16. And if I say log of maybe, I'm going to give you this one, it's actually interesting. So, not this one. So, maybe 2 and the square root of 8 is equal to, so we're going to talk about this. How does that equal to? So how do I change it to the log form here?
Log.
So log 2 of 16 is equal to 4, right?
Yeah.
Or 2 to the 4th power is equal to 16. Do I need to go over how to do that? No. But how about log 2 of square root of 8? And we say, I don't know how to do this, but we don't know what value is this. That means 2 to the what power is equal to square root of 8. So you say, hey, anytime we don't know, we're gonna put what? X, right? Or in elementary school, we put a box. 2 plus box is a 3. What is a box? Do you remember that?
Yeah.
In the old days, like 2 plus box is equal to 5, and what is the box? Fill in the box, right? So this one is an X. Now, can you do this problem?
Maybe.
No. You can do it.
The one in the bottom.
Yeah. It's,
Whoa,
Is it
whoa,
X?
whoa, whoa, whoa.
I can't see my answer. I can't see my answer.
No.
Can I say my answer?
Okay.
Yes.
You get.
I got 9.
What'd you get?
Oh, I got it. Let's go.
What'd you get?
I got 2 with the X on the top right equals square root of 2 with the 3 on the top right.
So, okay, square root of 2 and 3. Okay, good.
We got
Good. That's it?
I got X equals 3.
But this one, remember, this is a 2, right? So that's equal to 2 to the x equal to 2 to the what?
Is it 3 over 2?
Yeah.
2 with 3 over X.
X equals 3 over 2.
Oh,
That's equal to 3 over 2.
Oh, yeah, because I forgot there's a invisible 2 there.
Are we okay here?
Yeah.
So, so that's 2 to the x equal to 3 over 2, x equal to 3 over 2. So those are the things that you understand. So some of the homework like this is today. Okay, they're very easy. They're around 20 questions, but it really takes about 6 minutes. It takes 6 minutes. Of all the questions, this is a logarithm is the easiest homework of all time. Compared to rational, this is like a cake. This is a cake. Okay, so are we okay here? No, we're gonna go to a little bit more advanced, okay?
Oh, God. You better send home to them.
So we're gonna create some law. We're gonna say law of logarithms. So law of log. Okay, log. And we're gonna have a first law. We're gonna create a first law. Now, first law is really easy. Now, I want you to think about what is log of 2 of 2 is.
Log 2 of 2. 2 just 1.
Does it just say log of 2 or 2?
Wait, what?
So log of 2 of 2.
Oh, okay.
And what does that equal to?
2x equals
1.
2 to the x is equal to 2 to the first, right?
Yeah.
So therefore, x is equal to what?
1.
1, right? Does that make sense?
Yeah.
So this is x, right? 2 to the x equal to 2 to the 1, so x must be 1, so therefore this is equal to 1.
Yeah.
Does that make sense?
Yes.
But it turns out it actually applied to all of them. 5 to the what power equal to 5? 1. 10. So I can do log of 10. What if this is called common log? If it's a common log, what do we talk about? If a log is common, that means I don't write any subscript. If I have not subscript, this must be 10. That's what you use in chemistry. In Miss Singh's class, that's going to be using log 10, and the 10 is going to be the log. So that's going to be also 1. So it turns out the first law is pretty easy. The first law says log a, the base a, to the a is equal to what? 1. That's it. Ken, wake up. Okay, so that's the first law. The first law is the easy law. Are we okay here?
Yes, we are.
Yes, you are.
Okay, that's the first law. Okay? The second law, the first law was easy. Log a of a is equal to 1. And then you have the second law. The second law is we're going to create them. But we're going to give you 3 different things. And we're going to show you how it works. And you're going to see if applied to other thing works or not. So we're going to ask you a couple of questions. We're going to ask you log 5 to the 125 is? Do you guys know log 5 to the 125 is? 5?
I think it's 5.
3. 3.
Oh, yeah.
Oh, it's 3.
Yeah, it's 3.
It is 3. Oh my goodness.
5.
It's 3.
Right? So let's work it out, right? 5 to the x is equal to 125. 5 to the x equal to 5 to the third. So therefore x is must equal to 3.
Bro, you only said other letters. How do you get it?
Are we okay here?
No.
Wait,
Now, okay?
I get
give me a
it.
second, I'm trying to get it. Oh god.
Am I going too fast?
I got it.
Okay, so I'm going to give you another one. Log of 5 of 625.
That's just 4. Yeah, 4.
That's just 4.
That's 4.
There's not gonna work in it out.
Now we're going to show you something very, very cool. What if I add 2 logarithms? Does that equal to another logarithm of something else? So we're going to show you this visually. So we're going to show you this. So we say log of 5, we know what it is, plus log of 5 of 125. We also know what it is, right? We know that because of the first law. We know this because what we just got. So what do we know about this one? This answer is going to give me what? 1. This answer is going to give you what?
So you get
3.
4.
So now that's not a key. This we can evaluate so easily. We can do this all day long. But here's what the profound things that you can find. The profound thing is, what if I want to write in terms of log of 5? What would they be?
Log of 5 equals 620. Log of 5.
Well, 1 plus 3 is must be 4, but 4 is equal to something else,
625.
625.
right?
Yes, so then it'd be log of 5 and 625.
625, right? Do you guys see that? But pay attention here.
Multiply.
You add them. No, you
You
multiply
multiply.
them.
You multiply. 5 times 125 is what?
625.
625. So log property actually says very similar to like exponential rule. Remember, a to the 1 power, a to the 2 power times a to the 3 power is equal to what? A to the what?
2 plus 3.
So what happened here? Well, we have this. It must be means the 2 power are adding together. So we're going to create a second law, and we're going to see if it works or not in a second. So we're going to say log base of a of x plus log base of a of y is equal to log base of a of what?
Y.
X
X
times
times
Y.
Y.
X times Y. Does that make sense?
Yeah.
Let me write it out nicely, so that way you can have it. Is equal to log A of X times Y. Second law. And let's see if it works. Think about a number. Which number between 1 to 5?
4.
4. Okay, let's do 4. So if I have a log of 4, right?
Yeah.
And pick any number that's base of 4. 16, good.
And 64.
And then we're gonna plus log of what?
12.
4. Well, we need something that can workable.
64.
Okay, let's do 64. But that's kind of big. But
32.
34.
34.
The 32 don't work.
24.
128.
Oh, let's do 64. That's fine.
Yes.
I need a calculator though. Somebody need to borrow their phone.
Missed it
Oh
yet.
my God.
I'm too smart.
You're no longer Chinese.
I
You are
got
Chinese.
16 times.
It's just too big a number. But what happened is this.
It's 1024.
So 4 to the which power is equal to 16?
2.
2. 4 to the which power is
4. No.
3.
No, I lied.
3, right?
Yeah.
So 2 to the 3 is 5. But let's check what if a log 4 of 16 times 64. Anybody have a calculator? 16 times 64? 1024?
Yeah.
I don't know, do math.
Okay, so let's see. Log of 4 to 1024, see if it's true. 4 to the what power equal to 1024? Well, we know it's 5. So 4 to the x equal to 4 to the 5, right? If you type in a calculator, see if you do 4 to the 5, you got 1024.
Yes.
You got it?
Yeah.
Okay. So that we just proved that this rule works. We're gonna create a next rule.
Does it only work if the base is the same?
Yes, the base has to be the same. Great question, Daniel. Okay, so now we're gonna talk about the next one. What if you have log of what? Let's do 3. 27 minus log of 3 of 9. Good, that's a good question. So what if it's a minus? Think about which exponential rule that does help you, but remember.
Divide them instead.
Yeah. It'll be the 27.
So this one's 3 to the 27. 3 to what power is 27?
3 to the
There.
So, right?
That's 2.
2. So we know the answer is 1. But log of 3 of what number is equal to 1? The value has to be 3, right? Log 3 of 3. But what will be here?
3, because you have to divide.
27 over 9, yeah.
So wouldn't that still be 3 though?
Yeah. So what is 27 over 9? 3. Log 3 base of 3 is 1. 3 minus 2 is 1. Therefore, the third rule is this, what? If you realize this is the exponential rule, right? A to the n times a to the n equal to a to the n plus n. How about a to the n minus divide a to the n equal to a to the n minus n, right? So what do you think the rules here says? Log base of a,
X
x,
minus log base of
what is it? You did it. You just create a second law. And we're going to talk about third law and fourth law and fifth law, but those are the extension. There's total 5 that you need to understand, but right now we already go over 3. And if we understand those 3, we can solve a lot of ACT problems. The ACT problem is so easy. Literally 1 second you can find the answer. And you are like, okay, but SAT tests less on logarithms. But those are the things that you need to understand. So, comes back to done everything. Let's review everything. Log of A is equal to what? Log of A of x plus log of A y is equal to log of A of x times y. log of a of x minus log of a of y equal to log a of x over y. Now you're gonna see this. This is a cycle. Now what we're gonna do is we're gonna think about the next concept. So think about things that we can model that express the bacteria or the marker. What will be that function that can model that? Everything that you put in is gonna be double. The input in is gonna exactly get the same value. So what will be that model? X squared. So think about x squared. If I plug in 1, I'm gonna get 1, which is true, right? What happens if we plug in 2?
You get 4.
2 squared is also 4, which is, I don't think that's right? Let's try 3. 2 to the third power, 3 to the second power is gonna be what? 9. So that wasn't right. So think about this tomorrow. And we're gonna think about it.
I didn't get the.